So the easiest way to solve question 1 on page 172 would be to assume some values for mass and velocity. So it asks you what happens when the velocity of a car is doubled. So first I'm going to assume that the velocity of the car before you double it is 1 and the mass of the car is 1. So using the formula 1 over 2 mv squared, I calculate that the kinetic energy of the car prior to any changes made in the speed is 0.5 joules, or 1 over 2 joules. And for A, it asks us to double the velocity. So I just take 1, multiply it by 2. I can use this formula again, and I'll throw all the values into my calculator, and I get 2 joules. And 2 joules is 4 times 1 over 2 joules. So the answer for A is 4 times. And then you use a similar method for question B. It asks that the velocity is tripled, so you just use 3 for the velocity. You put it into your calculator, and you should get 4.5 joules, and then, 4.5 joules, and then you take 4.5 and you divide it by 1 over 2, and then you get that it's 9 times greater. Now for the last one, it asks that the velocity increases by 26%. So for the new velocity value, you just take 1 and you multiply it by 1.26, you get 1.26. So you put it back into the kinetic energy formula, you get 0.5 times 1 times 1.26 squared, and you get this value, 0.7938 joules, and then you divide that by 1 over 2, and you get 1.5876, or about 1.6 times greater, taking into account significant digits.